It's part 2. Here in part 2, we will see monosaccharide, that is D-glucose, it is dextrose, known as grape sugar, open chain structure of this D-glucose, open chain structure of D-glucose. Glucose is most important and abundant monosaccharide, aldohexose. In free state, it occurs in sweet fruit, particularly in grapes, and hence it is also known as grape sugar. D-glucose is also known as grape sugar because it occurs in sweet fruits and specifically in grapes. In combined state, it is present in disaccharides, for example, sucrose, maltose, lactose, etc., and polysaccharides such as starch, cellulose, glycogen, etc. It is colorless, sweet and crystalline compound having melting point 146 degrees Celsius. It is dextro-rotatory substance. Hence, it is also called dextrose. It is easily soluble in water. Then let us see preparation of glucose. Glucose can be prepared by hydrolyzing sucrose, that is cane sugar, with hydrochloric acid, that is HCl, in ethanol. So here sucrose C12H22O11 plus H2O. This sucrose upon hydrolysis we get glucose plus fructose C6H12O6 plus C6H12O6. Both the molecular formulas are same but they have different structural formulas. Commercially, it is prepared by hydrolysis of starch with dilute hydrochloric acid under pressure. Starch, it is polysaccharide C6H10O5N plus NH2O. Cl heat in under pressure gives N molecules of glucose C6H12O6. Then let us see open chain structure of D-glucose. The open chain structure of D-glucose is assigned on the basis of following considerations. So let us see points one by one. First, that is molecular formula, elemental analysis and molecular weight determination. Elemental analysis and molecular weight determination show that the molecular formula of glucose is C6H12O6. This is the first point. Second point is presence of 6 carbon unbranched chain. Glucose on complete reduction in presence of S hydroiodic acid Hi and red phosphorus give N-hexane, that is C6H12O6, that is glucose on reduction with red phosphorus and hydroiodic acid Hi. When it is heated, we get N-hexane 1, 2, 3, 4, 5, 6. So N-hexane, this proves that glucose has straight chain of 6 carbon atoms. Then third point, presence of 5 hydroxy groups. Glucose on acetylation with acetic anhydride form penta-acetyl derivative. Glucose C6H12O6. This is acetic anhydride. Upon acetylation, it gives glucose pentaacetate. This shows the presence of 5 hydroxyl groups. That means here in glucose there are 5 hydroxy groups. Such hydroxy groups are 5. As glucose is a stable compound, these 5 hydroxyl groups must be attached to different carbon atoms. Point number 4, presence of carbonyl group. Glucose react with hydroxyl amine to form oxime, and glucose react with hydrogen cyanide HCN to form cyanohydrine. This indicates the presence of carbonyl group, either aldehyde or ketone. And in point number 5, presence of aldehyde group. Whether that carbonyl is aldehyde or ketone, that is confirmed in this point. Glucose on mild oxidation with bromine water gives gluconic acid. This glucose C6H12O6 on mild oxidation with bromine water gives gluconic acid C5H11O5COOH. That is monocarboxylic acid. Only one COOH group is there. Monocarboxylic acid containing same number of carbon atoms, which on reduction by HI, that is hydroiodic acid, gives N-hexanoic acid. This shows that glucose contain an aldehyde group. The CHO group, being a monovalent, must be at one end. Point number 6, presence of primary alcoholic group. Gluconic acid on further oxidation with concentrated nitric acid HNO3 gives glucaric acid, a dicarboxylic acid. That is, this is the reaction. Gluconic acid upon further oxidation with the help of nitric acid gives glucaric acid COOH C4H8O4 COOH. That is dicarboxylic acid 1 and 2 carboxylic acid units containing same number of carbon atoms as glucose. As glucose contain one aldehyde group, as already shown, the second COOH group must be obtained from the oxidation of primary alcoholic group. Hence, glucose contain primary alcoholic group CH2OH. From the above evidences, from the above all evidences, it is concluded that glucose is pentahydroxyhexanal. That means 5 carbon atom, 5 5 OH pentahydroxy, 5 OH and 6 carbon atoms and 1 aldehyde. In 1870, Bayer proposed the open chain structure of glucose as, so this is one aldehyde, this 1, 2, 3, 4 and 5 hydroxy group, and among 5 hydroxy group One is primary hydroxy group, that is CH2OH. So this structure is proposed by Baer in 1870. This is the open chain structure of glucose. In summary, the evidences in favor of open chain structure of D-glucose are as given below. So, by reduction with red phosphorus and HI, we get an hexane. This indicates the chain of 6 carbons. Then acetylation with the help of acetic anhydride gives glucose pentaacetate. This indicate that there are 5 OH groups are present, 5 hydroxy groups are present. When hydroxyl amine react with glucose, it gives oxime, which indicate carbonyl group. When hydrogen cyanide is reacted with glucose, it gives cyanohydrine, which indicate that the aldehyde group is present in glucose. With the help of bromine water, when mild oxidation takes place, it gives gluconic acid, and further reduction with HI, it gives N-hexanoic acid. And concentrated nitric acid oxidizes glucose into dicarboxylic acid, that is glucaric acid. It gives the information about the primary alcohol. This collectively supports the open chain structure of glucose. Here, this oxime formation and cyanohydrin formation confirms presence of carbonyl, and this mild oxidation by bromine water, formation of gluconic acid and further reduction to form hexanoic acid gives information about aldehyde group. This COOH is formed by oxidation of aldehyde group. And here this last reaction proves the presence of primary alcohol CH2OH. Thank you.